Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to talk about the acid-catalyzed keto-enol tautomerization. This is also known as an isomerization reaction. This reaction is generally promoted by both strong and weak acids, and they are catalytic, which means that the acid is regenerated during the reaction. The equilibrium favors this keto form, or a ketone, as opposed to an enol, and Le Chatelier's principle helps to drive this reaction forward. If the enol is formed during this reaction, it will become the keto and in a subsequent step, react with nucleophiles or bases. Let's get into the mechanism. So I'm going to show the reaction for a generic enol interconverting to the keto form in the presence of acid. I'd first like to focus on the resonance forms that are possible with this enol. Remembering that there are two lone pairs on oxygen, we can kick these electrons down to form an oxygen-carbon double bond and move the double bonded electrons onto this carbon right here. This makes a species that looks like this, right, which is zwitterionic. Now, the resonance structure on the left, of course, is the more favored resonance form. Because we have all of the octets satisfied, there are no charges, and there's no charge separation. Whereas the one on the right is the less favored resonance form because we have a positive charge on oxygen, we have resonance forms, we have charge separation, and this makes it the less favored resonance form. But even though this one on the right is less favored, it does give us a hint about the reactivity. The negative charge on that carbon tells us that carbon is relatively nucleophilic, and it's that indication that helps us through the mechanism for this reaction. So if we use the electrons here on oxygen to reform this carbon-oxygen double bond and use the pi bond itself to deprotonate hydrochloric acid, then we have a compound that looks like this. We've added a hydrogen to that nucleophilic carbon, right? And we have now a protonated carbonyl. The chlorine is the conjugate base, and this chlorine can deprotonate that acidic hydrogen on the carbonyl to regenerate hydrochloric acid, plus now the keto isomer. This can also be done with base, which is the subject of the next episode. For now, I'll leave you with some questions you can ask in office hour. 1, why is the keto formed? 2, how fast is this reaction? Does it depend on acid strength? 3, does this occur in biological conditions? With that, this has been Organic Chemistry in 5 minutes or less. Thanks for tuning in.